Cool. Very cool. And since you're giving us a few use cases, can you go into a bit more depth on other use cases that you've had? And
Sure. Um, should we talk maybe more on, just to like keep the ball rolling? Let's talk more about use cases and then maybe related to the serving side of things.
yeah,
Um,
perfect.
yeah. So um, we developed essentially a machine learning services gateway that acts as our one place for all machine learning services. So essentially, if you want to call any ML model, you hit our machine learning service gateway. You let us know which model you're looking to hit. And if there's any A/B testing you're looking to do specific to model versions and such, you can pass that in. And then we pass in the data needed for that model to make an inference. And what we want to do is make it super easy for our partner services to integrate with us. So when I say pass in the data needed to make an inference, I don't mean all of the raw features that are needed to make a model inference. I might mean, oh, they just give us the user ID or the survey ID. And then from there, we know for each model what features are needed. We go hit our real-time feature store, get those features, and then we have essentially model project pods, which are just clusters of um, nodes that are all running the same Docker image or various different versions of Docker images if we're doing proper versioning and A/B testing. And then they've received all the grab that in, we go hit those nodes, get our inference back, and then return the result to our whoever called our service.
So can you
Um,
just repeat that last part? I think you may have broken up a little bit.
oh, sure thing. So basically, we have like a high level gateway. We receive all requests. We go hit our real time feature store, grab our features. Then, based off of whatever the API parameter inputs are of which model we're looking to hit and which version, we go hit. We have an Nginx routing layer in between that helps us route based off of these params which nodes we should be hitting to make our inference. We go make our inference and it travels back up our path to then return our result to our users. And so there's essentially a load balancer that sits right at our gateway layer. And then we have a router that sits at right below our gateway to route which nodes we should be hitting um, to make our inference. And we're able to do this now both synchronously and asynchronously because some of our models are super heavy and say they might take on the order of seconds, but our um, um, our partners want to be able to receive a result, or at least know that they made the right call, made the right request pretty quickly. And so what ends up taking place there is asynchronously will return like, hey, yeah, we got your request. Here's your ID. Ping us whenever you need to display result to the user, and then we can go ahead and do that. And so we're able to overcome and the reason why we did this is we had some hurdles on the infrastructure side. We couldn't support some models that needed GPUs to run very quickly, and this was mainly due to like say our infrastructure team have some like we couldn't get those GPU enabled clusters or nodes, and so as a result we're running some things on CPUs. They're a bit slower, but we're able to still meet our requirements for delivering really quick results to our users. And a use case that kind of demonstrates synchronous versus asynchronous is we have a machine learning model feature called SurveyMonkey Genius. So this is a feature that sits on the create side of our SurveyMonkey platform. So when you're creating a survey, you know, oh, all good. When we're creating a survey on our platform, we want to help our users create optimal surveys. So we provide them with an estimated completion rate, estimated completion time, and some recommendations for how they can better their survey so that it's more likely to be completed. And so these are backed by a couple of different machine learning models, but we want the result to appear real time as the user is creating their survey so that they can make the changes to their survey almost immediately. And so this is the case of, say, synchronous inference architecture, a synchronous inference call. But then there's a use case of asynchronous inference call, say when we're doing some heavy analysis upon our surveys and want to return some outputs on, say, the sentiments of every response for the survey that you're looking at. You know, you can get millions of responses on your survey. Getting the sentiment for everything can take quite a while. So in those cases, we're like, okay, yeah, let's use our asynchronous architecture. It'll take us a couple of minutes for us to get you, you know, the overall distribution of sentiments and such things like that. And so let's use our asynchronous architecture, and you know, our users are okay with that, and we've been able to deliver on that for them as well in an efficient manner without bogging down our infrastructure too much.